Good afternoon. We will discuss probability. Remember? Okay. Then basic concepts. Yes or no? Speak. Then the first one is joint probability. Okay, there are two concepts, joint and the marginal probability. Okay, joint probability means is defined as the joint occurrence of the two or more events. Joint. Okay, then this is the joint of the occurrence of the two or more events. We not get the probability of the one event, single event. Always we check the probability value for the joint of the occurrence of two or more events. Okay, this is the example. Consider the following table which shows the results of a hypothetical survey in the 10,000 individuals were asked whether they favor increased defense spending. 10,000 persons classified by the attitude towards increased defense spending and political party. Okay, this is the survey result. Okay, this kind of table we call as a contingency table. Remember, second chapter we discussed how to present the categorical data. Okay, the first thing is using the tabular format. Okay, then we have more than one categorical variable, we use contingency table. Okay, then this is one kind of contingency table. Okay, in here we have two kind of variables. What are they? Political party. Another one is increased defense spending. Okay, then in here there are two categorical variables in here. Okay, then these are the results of that hypothetical survey. Okay, in the joint probability means then we need to get the probability of that the person favors increase their defense spending and that person is a Democrat. Okay, then we talking about the probability value for the two events. Okay, then how many of them are? Their political party is a Democrat and they favors increase their defense spending. How many of them in here? How many? Their political party is a Democrat. Okay, and they favor increased defense spending. How many of them? These two events now. Okay, how many of them? 2,500. Okay, out of 10,000. Understood? That is we call as the joint probability. We taking the probability value of the two events or two or more than events. Okay, then they favored increased defense spending and their political party is Democrat. What is the probability? Then we join these two events together. What amount? 2,500 out of 10,000. Okay, normally in the probability, we write in the probability value. Normally we write it as a fraction. Okay, denominator means what? Total number of cases in here. Okay, in this survey, how many persons are there? 10,000. Numerator, we write it as a number of favorable cases. Okay, in here, their political party is a Democrat and they favor increased defense spending. How many of them? 2,500. Then what's the probability? 2,500 over 10,000. Understood? Second, first one is same probability that the selected person is a Democrat and does not favor increased defense spending. It means what? This one says selected person is a Democrat. First, other one is and favor increased defense spending. Normally, and means in the probability concept we call as intersection. Okay. Then here ask probability that the selected person is a Democrat and does not favor increased defense spending. How many of them? Political party is a Democrat. Okay. Then does not favor increased defense spending. How many of them? 3,500. Okay. How to write the probability value? 3,500 over 10,000. Understood? Then go to the third one. Probability that the selected person is a Republican and favors increased defense spending. Their political party is Republican. Okay, then their favoration for the increased defense spending. Then we looking at how many of them. Republican and favors increased defense spending. How many of them? 2,500. Then probability value is 2,500 over 10,000. Now clear? This is the way we can write the answer for the joint probability scenario. Understood? In the joint probability, we take the probability value of the joint occurrence of the two or more events. Okay? Then other concept we call as marginal probability. Okay? Then the opposite of the joint probability. In the marginal probability, we take the probability value of the single event. Okay, always we talking about only one event. Okay, then in here, marginal probabilities show the proportion of observation that poses any single specific characteristic. Always we take the probability value for the single event. Okay, then first one, marginal probability that the randomly chosen person favors increased defense spending. And then this statement talking about only one variable in here. What is it? What is the single event in here? Favor increased defense spending. Okay, then total is how much? Favors increased defense spending. Only this column. Okay, total of this column. How much? 5,000. Then we can write 5,000 over 10,000. And then move to the marginal probability that the randomly chosen person in this group is a Democrat. That is the probability. Then the person who is from Democrat. What is the total value? 6,000. Okay, understood? Joint probability. It's clear. Joint probability, we take in the probability value of the joint occurrence of two or more events. In the marginal probability, we talking about only probability of the only one event, single event. Understood? Using the contingency table, in the marginal probability concept, we take the row total or column total value only. Okay. In the joint probability, we take the joint occurrence. Joint value. Understood? It means intersection. Clear? Understood? Okay. Here, do the section number 1. We do the part 1 and part 2. Okay? Now do the problem number 3, only 1 and 2. This is the contingency table. Suppose the study of speeding violations and drivers who use cell phones produce the following fictional data. Okay. Then first, in the row side, we number of cell phone users and who are not using the cell phone. Then speeding violation and the no speeding violation. Then answer the part 1 and part 2. Finished? Shall we discuss? Okay. First one are find the probability that the person is a cell phone user. Okay. Then which concept behind that? First one, marginal probability or the joint probability. Marginal probability. Okay, only one event in here. Then how many of them are cell phone user? 305 over 765. Okay, understood? Part 2, find the probability that the person had no violation in the last year and was a cell phone user. Second one, discuss about the two events. Okay, then they are cell phone user and they had no violation in the last year. No speeding violation and they are cell phone user. How many of them? 208 over 751. Clear? This concept is okay. Joint and the margin. Another concept is conditional probability. Okay. Conditional probability means we taking the probability of the one event occurring the given that another event. Okay. In the conditional probability, we talking about the two events. Okay, but not these two both events occur together. Understood? In the intersection means both events occur together. In the joint probability, say two events occur together. Okay, but in the conditional probability, we discuss about the two events, but one event, probability of the particular event, other event has already occurred. It's clear that we call that the conditional probability. It's clear. Probability of an event occurring given that another event has already occurred. they think we consider about two events A and B. We need to get the probability value for the event A. Okay, but event B has already occurred. Understood? Then what is the first event in here? A or B? B. Why? This event has already been occurred. Okay, then after that occur the event A. That we call as the conditional probability. In the English, we use the if clause now. Using the conditional. Understood? Okay. Then this is the way we can write the conditional probability. This probability of B given A. Normally we say B given A. Okay, but this is the first event in here. A is the first event in here. This is the second event. Understood? Then it means we need to get the probability value of the event A, not the event B. Okay, occurring given that the event B has already occurred. That is the meaning of the conditional probability. Okay, but we write it as the using the notation in the probability notation. We say B given A. A is the first event, B is the second event. Understood? A is the first one, B is the second one. It means we need to get the probability value of the event in here. Then which event has already occurred? Event A or event B? In this one, event A. Understood? Why event A is the first event? In here, we write the first event. The second event. We need to get the probability value for the event B. Okay, given that event A has been already occurred. Understood? Then this is the formula we can get the probability value. Conditional probability. We say B given A. Okay, B given A means A is the first event, B is the second event. B given A. Okay, then this is the formula. Numerator, you need to express the intersection of the given two events. In here we discuss event A and event B. Okay, then this one is express the intersection of the event A and event B. Understood? Then the denominator is the probability of the first event. Okay, that is the way we can find it now the conditional probability. Intersection of the two events divided by the probability of the first event. Understood? Sure. Then this is the first event, this is the second. Okay, then we need to intersection, then divided by the probability of the first event. In here, first event is A, then probability of A. Understood? Okay. Then read the part 3, Roman number 3, first reading. What is the probability a randomly selected person is a cell phone user given that they had no speeding violations? Okay, there is a hint word given that. Okay, it is a hint word for the conditional probability. Okay, then it is this section number 3 discusses about the two events. Okay, but these two events are not occurred together. Why? Then this one says probability a randomly selected person is a cell phone user given that they had no speeding violation. Okay, then it means we selected the person, he or she is a cell phone user. Okay, then given that they had no speeding violation. What is the first event in here now? No speeding violation. What is the second event? Person is a cell phone user. Okay, then how to write this kind of questions through this contingency table? First, you move into the first event. They had no speeding violation. Okay, then how many of them are no speeding violation? 655. Then we need to get the probability value of the cell phone user. How many of them are cell phone users? 280. What is the answer? 280 over 685. Understood? It's clear? Okay, then using the formula, how to get the value? Then cell phone user, the event A, no speeding violation is the event B. Okay? Understood? Then how to write the conditional probability? First is the speeding no speeding violation. Then write the A. Okay, A given B. Okay, then what is the formula? Intersection B over probability of the first event. Okay, it's clear? That's the structural formula to find the conditional probability. Then tell me probability of the intersection. The person is a cell phone user and he or she had no speeding violation. What is the probability? This one. Okay, then how to write the probability value? 280 over 755. Numerator is 280 over 755. Divided by probability of the event B. What is the probability of the event B? Tell me, what's the probability of the event B? 685 over 755. Then what happens? In the division, normally the fraction, then this one is 280 over 755. Okay, divide by this amount of, in the fraction we put the multiplication sign and write the reciprocal of that particular fraction. What is it? Reciprocal means change in the numerator and the denominator. Then 680. Then what happens? These values are cancelled. Okay, what is the final answer? 280 over 680. Understood? Using the formula, this way we can calculate the conditional probability, or you can use the contingency table. Okay, the contingency table, first you look in at what is the probability, what is the total amount in the first event. In here, first event is that they had no speeding violation. First we look in at how many of them had no speeding violation. In here, 685. Then move into how many of, out of that, how many of them are cell phone users. Okay, then how many of them are? 280. Then we can write 280 over 685. Understood? This is the concept of the conditional probability. Okay, in the joint probability we discussed the two events, two or more events, but all the events have been occurred together. Okay, then all the events occur at once. But in the conditional probability we discussed two events, but these two events has not been occurred together. Okay, then we need to get the probability of the one event. but another event has been already occurred. It's clear? Okay. Clear now? Joint probability, marginal probability, and the conditional probability. Other one is independence of the two events. All of you know what is the meaning of the independence means? No depend on the other. Independent means that one. Okay? In the probability concept, independent means that we take the two events A and B. Okay, then these two events have no influence on one another. We call as A and B are independent. Okay, then A and B, event A and B have no influence one another. A do not depend on the B does not depend on the A. Understood? That's the meaning of the independence of the event. Okay? When events A and B have no influence on one another, we say that events A and B are independent. Okay? Then if the events A and B are independent, the probability of the occurrence of any one of them does not depend upon that of the other. Okay? It's clear now? Normally independent means these events are not dependent on the other event. Okay? Then if the two events are independent, okay, then these are satisfied. Okay? Then first thing is, two events are independent, we need to get the intersection of the two events. Okay? How to get that? Then think A and B are independent. How to get the intersection? Event A multiplied by the probability of the event B. Understood? Intersection. Intersection means both. Okay, how to get the A intersection B? Probability of A multiplied by the probability of B. Only if the two events are independent. Okay, then scenario or equation says there are two events A and B. It's not specifically saying that these two events are independent. We cannot get the intersection using this formula. Okay, only this one applicable to events are independent. Understood? If A and B are independent, we need to get the intersection. We can multiply by the probability of the two events. Understood? Okay. Then other one is, now you know the conditional probability. Okay. Then how to get the conditional probability? Then probability of A given B. Okay. Then this is the formula. A intersection B divided by probability of the first event. This is the structural formula to find the conditional probability. Okay? Then think A and B are independent. Okay? Think we assume A and B are independent. Then A and B are independent. How to get the intersection? A and B are independent. How to get the intersection? BA into BB. Then we can write BA into BB divided by BB. Okay. Now what happened? We can cancel this BB to this BB. What is the answer? BA. BA means what? In this example, what is the meaning of the probability of A? Probability of the second event. Understood? Then if the two events are independent, in the conditional probability is equal to probability of the second event. We do not need to formula to find the conditional probability. Understood? If the A and B are independent, we need to get the probability value for the B given A. In here, what is the second event? B. Then this is equal to the probability of B. Understood? Then A given B. What is the second event in here? A. It is equal to the probability of A. Understood? Okay, only these three are applicable to the if A and B are independent. Okay, then these two events are dependent. We use the formula to find these probability values. Okay, we need to get the probability of the intersection. We can use the additional law of probability. Okay, then we need to get the conditional probability. We use the formula. But these two events are independent. How to get the intersection? Multiply the events, probability of the events. Then we need to get the conditional probability that is equal to the probability of the second event. Understood? Okay. Question number 3. Question number 3. Okay. Assume that for two events A and B. Okay. There are two events we call A and B. Probability of A is equal to 0.65. Probability of B is equal to 0.80. Okay, then these are the two probability values. Then A given B is equal to probability of A. Then other one is B given A is equal to 0.85. Question asks, is this a correct assignment of the probability? Okay, these assignments are okay or not? Question asks that. Understood? Okay. Then these are two probability values. Okay. Then other one says A given B is equal to PA. What does mean? A given B is equal to probability of A. What is the meaning of that? These two events are independent. Okay, then therefore they say A given B is equal to PA. Okay, then based on that, we can assume A and B are independent. Okay, then what happened to this one? B given A is equal to 0.85. Then A and B are independent. What is the answer for that one? Probability of B. Okay, then probability of B value is how much? 0.86. But question is given 0.85. Then is the correct or wrong? Wrong. That is not true. Okay, then you can explain it. First you write this one, A given B is equal to PA. Okay, then therefore we can assume A and B are independent. Okay, you can write it this way. Then you take this one. B given A is equal to 0.81. Okay, then assuming A and B are independent, what is the probability of B given A is equal to probability of B. Then value of the probability is 0.80. Okay, but this one is given the 0.85. Understood? Then we can say this is the correct assignment. Understood? It's clear? Okay? Yes or no? Question number 2. Last week we discussed question number 2. Then read the question number 6. Question number 6. Number 6. An item manufactured by a company consists of two parts A and B. In the process of manufacture of part A, 9 out of 100 are likely to be defective. Probability of the defective in the item A. Okay. Similarly, 5 out of 100 are likely to be defective in manufacture of the part B. Okay. Calculating the probability that the assembled item will not be defective. Okay, then final output will not be defective. Okay. Then how to get that? Then final output will not be the defective means A not be defective and then B also not defective. Okay, then add them together, we can get the non-defective item. Okay, then how to get the probability value? Then both will be non-defective. Part A and part B. Understood? Okay, then how to get the probability value? What is the probability of the part A will not be defective? What is the probability? 91 over 100, 0.91. Okay, then what is the probability of the part B will not be defective? 95 over 100. Okay, then we need to get the probability of the final output will not be defective. Okay, then if the final output will not be defective means part A will not be defective and also part B will not be defective. Okay, then it means we need to get both will not be defective. Both means what? What's the concept in the probability? Both means intersection. Okay, then we need to get the probability of A intersection B. A intersection B. No? Okay, then what is the answer? How to get that? There's no other details are given. We can assume these two events are independent. Part A does not depend on the part B. And then these two parts manufactured separately. Okay, then these two events are independent. Then how to get the intersection? Multiply the two probability values. What is the answer? 91 over 100 multiplied by the 95 over 100. It's clear? Okay, understood? Of the part A will be defective. But in B, the probability of the final output will not be defective. Will not be defective means also part A will not be defective. A का defective වෙන්නේ නැහැ defective වෙන්නේ නැති වෙනවා. එයත් හොඳ වෙන්නේ. So 5 out of 100 is the probability of the defective. What is the probability of non-defective? 1 minus that. And it means 0.9 1 into 0.9. It's clear now? Yes. The last two concepts in the probability, okay? Total probability law and the Bayes theorem. Okay? Let's start. Total probability law and the Bayes theorem. This is the last part of the probability lecture. Okay? Total probability law means then we take the particular scenario, okay, then think this way. In a factory, they produce a particular product. Okay. And then finally, we produce the one kind of product. Okay, but in the factory, they use 3 machines to produce the one product. Okay, A, B, and C. Understood? Okay. In a factory, they have 3 machines, A, B, and C. Okay, then they can use these 3 machines to produce one kind of a product. Okay, then their total production 20% of their production to produce that particular product, they use the machine A. Understood? Okay, then 30% of the production to produce, they use the machine B. Okay, then what is the remaining part? 50%. Okay, then 50% of the production using the machine C. Understood? Their total production is 100%. Okay, then 20% of the production are produced using the machine A. 30% of it are produced to use machine B. Rest of the production using the machine C. Understood? Then there will be a chance to getting a defective item. Okay, then they check in their quality level. Then there is a chance to getting a defective item. Okay, then machine A is the 5% chance of the getting a defective item using the machine A. 5%. Okay, then machine B 2%. Okay, then 2% of the production. Understood? Then sorry. Guys, total production is 30% in the machine B. Okay, then out of that 2% may be a defective item. In the C, 1% may be the defective. Understood? Okay. Then these are the 3 different machines. Okay, then but now we discuss their common event. What is the common event in here? Then I say, then there are 3 machines A, B, C. First I wrote the particular probability value of using the machine A, B, and C. Okay, then we discuss then output of the probability of the getting a defective item through machine A, through machine B, and the machine C. Okay, then what is the common event in here? Yeah, then output may be a defective. That's the common thing now. Using the machine A, machine B, or machine C, we can get the defective item. Okay. Then we use in the machine A, then get the output. What happens? 5% of them are defective. Then we use in the machine B to our production, but 2% may be a defective. Then we use the machine C to our production. What happens? 1% may be the defective. What is the common thing we discuss? Defective. Okay, then we need to get the probability of the defective item that we call as the total probability law. Okay, then output may be a defective. That is the common thing. Common to the machine A, B, and C. Okay, then we need to get the probability of we select the item. That item is defective 1. Then we need to get the probability of of it. Probability of getting a defective item. Okay, that we consider as the probability of the common event. That common event we express as the total probability loop. Then we finding out the probability of the common event we call as the total probability loop. Understood? Then they are consider about the 3 or more events, but finally we have only one common thing in here. Understood? Okay, that we call as a total probability loop. Okay? Then in here, when we use in the total probability loop, there are 2 conditions in here. First one is these events are mutually exclusive. Now you know the concept of the mutually exclusive. What is it? Mutually exclusive means last week we discussed mutually exclusive means union value is equal to 1. Okay, then it means then there are 2 or more events. Then all the events cover the full sample space. We told that this is the mutually exclusive. Then your union is probability of the union is equal to 1. Okay, then our example 0.20 plus 0.3 plus 0.5. What is the answer? It means these 3 events are mutually exclusive. Understood? Then other one is that is a collectively exclusive. Mutually exclusive means what? There is no any intersection. Okay? Mutually exclusive means there is no any intersection. It's true, no? Then we have 3 separate machines, A, B, and C. Okay, then we use in the particular machine to our production. There is no any intersection. Okay? Then collectively exhaustive means what? Then your union value is what? Okay, it's true. 0.2 plus 0.3 plus 0.5 is equal to 1. Okay, then another thing is mutually exclusive. Mutually exclusive means A, B, and C. Okay, then we cannot produce the one particular product using both machines. Okay, then this example says then in a factory they have 3 machines. They use any one machines to produce that particular product. Okay, then 20% of the production are used machine A. Okay, then produce the 30% of the production are used to machine B separately. Okay, there is no any intersection in here. Mutually exclusive. Then other one is collectively exhaustive. Union value is equal to 1. Union means all the elements. Okay, then collectively exhaustive means your union cover sample space. Okay, then we took the example for that. Then rolling a dice, what the sample space 1 to 6 now. Event A is getting an even number. Event B is getting odd number. Event A means 2, 4, 6. Event B is 1, 3, 5. Then what is the union in here? 1, 2, 3, 4, 5, 6. Then what happened? The union. Union and the sample space are equal. Then your union value is equal to 1. Understood? It's clear. That is we call as the collectively exhaustive. It's clear. Then these 2 conditions are okay. Then we can use the total probability loop. Okay, then this picture shows that one. Then there are events in here. A1, A2 to the AN. Okay, then there are events. Then these events are separately. It means there is no any intersection. And other thing is this cover all sample space. It's a red diagram. Okay, then this circle shows the common event B. Okay, then we need to get the probability of this common event. We call that the total probability load. Okay. Other way we can use the tree diagram to answer the question about the total probability load. Okay, then you know the tree diagram. First one is we have three machines A, B, and C. Okay, then what's the probability value? 2%, 20%, 30%, 50%. Okay, then effective. Then we use in the machine A to our production. What is the probability of getting a defective item? 5%. Okay, then we can say maybe a defective 5%. Okay, then maybe the non-defective 95%. Okay, then using the machine B, we use to produce that kind of output. What is the probability of getting a defective? 2%. Then we can write probability of defective is 2%. Then C, using the machine C, 1% is the probability of getting a defective. Okay, then what's the common event in here? Getting a defective item. Okay, then we can say probability of D. How to get the probability of D now? Then how many chances in here? 3. Right? Using the machine A, we can get the defective item. Okay, then when we use the machine B, we can get the defective item. We use the machine C, we can get the defective. Okay, then we have 3 chances. This one, and this one. Okay, then sum of these 3 events we call as the probability of D. Okay, then how to write? Then this value we call as probability of A. We can write A intersection D. Both we use the machine A and we get the defective items. Okay, that is the concept in here, intersection. Then second one, B intersection D. Plus other one is C intersection D. Clear? Okay. Then how to get the intersection value in here? A intersection D. How to get the answer? This value multiplied by the 0.2 multiplied by the 0.05. How to define that value? 0.2, we can write probability of A. That is multiplied by this value. How to define this one? 5%. How to write using notation? 0.05. How to write? Yeah. A given. Not A given D. Other way. No? D given A. Okay, then this one is using the machine A, we produce, okay, that output is the defective one. Understood? What's the first event now? A. Second event is D. Then how to write it? Understood? That 5% we indicate this way. It's clear? Using the conditional. Okay, then we already produced now using the machine A. Okay, then what we searching about, then 5% are the defect. First event is using the machine A, we produced it. Then the second event is that output will defective one. Understood? Then task. How to write it this one? B intersection D. 0.3 into 0.02. Then 0.3 we write it as probability of B. Okay, then multiply T given A. Okay, this is the same. Probability of C multiplied by the T given C. Okay, then you can take the value. How to get that? First one is 0.2 into 0.05. What is the answer? 0.01. Okay, then plus what is the answer in here? 0.006. Then this one 0.005. Okay, then take the sum, we can get the probability of the common E. Understood? This is the formula we can use. Okay. Then you can directly use this formula to get in the probability value. No need to draw the tree diagram or the Venn diagram. Okay, you are familiar to this concept. You can use directly formula to get the probability value. Understood? Okay. First you write this example, then we try the question. Okay. Oh, oh. Then another one is probability of C into D given C. Try the question number 8. To define the event, and you can write the formula too and substitute the value. The groups of candidates are competing for the position of the board of directors of a company. The probability that the first and second sets will win are 0.6 and 0.4 respectively. That's the probability of winning that particular group. If the first group wins, the probability of introducing a new product is 80%, 0.8. Corresponding probability if the second group wins is 0.3. What is the probability that the new product will be introduced? Okay. It means there is any group will be win, then what happens finally? New product will be introduced. That is a common event in here. Question asks what is the probability of the new product will be introduced. And then we can apply the total probability law. Why? Then question asks the probability of the common event. Okay, how to get the values? What is the answer? 0.6 into 0.8 plus 0.4 into 0.3. But now 0.48 plus 0.1 to 0.60. Understood now? Total probability concept? It's okay. Then always you read the question and understand question asks what. Okay, what is the ask from the question? Okay, then in here, the question asks the common event, probability of the common event. Then we can use the total probability law. Understood? Okay. Clear the total probability law? As the last concept in here, the Bayes theorem. Bayes theorem. Okay. That's the same as in the conditional probability. Okay. Conditional probability takes into account information about the occurrence of one event to predict the probability of the another event. We need to take the probability of the particular event based on the prior knowledge of the given condition. That we call as the Bayes theorem. It's clear? That's the same as in the conditional probability concept. Okay? And therefore, we use the same formula in here. A given B. In here, first event is probability of B. Okay? The numerator we express as the intersection. Other way, we can write it this way. In the total probability law, how to get the intersection? First event multiply by their conditional probability value. Okay? It's the formula. This concept can be extended to revise the probabilities based on the new information and to determine the probability that the particular event effect was due to the specific cause. Then first we identify the thing. We move the previous example. Another example. First example. Okay, then there are three machines A and B, A, B and C. Okay, then we find out the probability values of the getting and defective items using the machine A, machine B and machine C. Okay, the total probability law concept define what is the probability of the common event. Okay, then we take the probability of the single event. But in the Bayes theorem says that it is the same values. Okay, we see probability of the production and this is getting a defective item. Probability of the getting the defective items in each machine. Okay, in the Bayes theorem says we select the item. Okay, then we have then production is now finished. Okay, then we have the total output in here. Okay, then first we select output. That output is a defective one. Okay, then we select the output that is a defective one. Okay, then we search in which machine is produced that particular event, that particular output. Okay, Understood? Then we select the output. That's the defective one. Now we're looking at which machine is produced that output. Then that product produced by using the machine A. Okay. Then what is the probability of it? We call that Bayes theorem. We revise it. We take the revised probability value. Okay. Then we take the defective one. Okay. Then we looking at which machine is produced that defective output. Okay. Then we can get the idea that product was produced using machine A. Okay. Then what's the first event here? Output is a defective one. Based on that was produced using machine A. Then how to write it? A given D. By first event we write it as the second place. A given D. How to get the probability value now? How to get the probability value using the conditional concept? Then we finding out the product that is the defective one. Okay, given that we looking at which machine is used to produce that defective one. Okay, then we finding out that is using the machine A. That we call as the Bayes theorem. Okay, then first we identify the probability of the common event. Okay, then based on that, we finding out the probability of the prior event, prior incident. Okay, then how to get the value in here? Now you know, it's the conditional probability. How to get that? Probability of intersection of the two events divided by probability of the first event. Okay, then probability of the first event is what? Probability of D means what? Probability of the getting a defective item. That is the answer of the total probability. No. Yes or no? Yes. No. Probability of D means answer of the total probability. Okay, then the example, what's the answer? 0. 0.021. That's the total answer for the total probability. Probability of getting a defective item is equal to 0.021. Okay, then this one is getting a defective item. That defective item is produced using the machine A. Okay, then we take the probability value of the revise. Okay, then finding the revised probability values. Okay, then how to get the value? Then probability of T is the total probability of answer 0.021. What is the answer of it? This one. A intersection D. What is the answer? Now you have the answers. Look, previous example. Intersection D means what? 0.2 into 0.05. Yes or no? A intersection D means first branch, no? 0.2 into 0.05. And we can write 0.001. What is the answer? 1/20. Understood? Total probability law concept we using to finding out the probability of the common event. Okay, in the Bayes theorem, same as in the conditional probability concept, by taking the revised probability. Revised law. In the tree diagram, we revise it. First, we take the item that is the defective one. We revise it. We search in which machine we use to produce that defective item. Understood? Then we find out machine A and we revise it. It's clear? Okay. Then that we call as the Bayes theorem. Understood or not? Clear? Okay. Let me move into the picture, then you can get the idea. Then read the section number 9.
theory section
1% of all the individuals in a certain population are carriers of a particular disease.
1% of the population, okay,
carriers of a particular disease.
එක රෝගයක් තියෙනවා මේ ඉන්න ජනගහනයේ 100%ම ඒ රෝගේ තියෙනවා.
හරිද? 1%. Okay. Then diagnostic test of this disease has a 90% of detection rate for the carriers.
හරිද? දැන් අපි ඕනිම ලෙඩක් තියෙනකොට ඒක ඩයග්නොස් ටෙස්ට් එකක් කරනවානේ. එක්කෝ බ්ලඩ් ටෙස්ට් කරනවා. මොන හරි ටෙස්ට් එකක් කරලා චෙක් කරනවානේ මේක තියෙනවද නැද්ද කියලා. හරිද? එතකොට දැන් 100%කට තියෙනවානේ. එයාලා තමයි කැරියර්ස්ලා වෙන්නේ. රෝග වාහකයෝ වෙන්නේ එයාලානේ. ඒ 100%. හරිද? ඩයග්නොස්ටික් ටෙස්ට් එක කරාන් පස්සේ ඒ රෝගේ ඇත්තටම තියෙන අයගෙන් 90%කට අර ටෙස්ට් එකෙන්වත් ප්‍රූව් වෙනවා මෙයාලට මේ ලෙඩේ තියෙනවා. දැන් 100%කට තියෙනවනේ 99%කට නෑ මේක. පේන විදිහට නෑ. හරිද? ප්‍රූව් කරගන්න හොස්පිටල් එකෙන් ටෙස්ට් එකක් නේ කරන්නේ. හරිද? ටෙස්ට් එක කරාන් පස්සේ then diagnostic test of the disease has a 90% of detection rate for detect කරනවා කියන්නේ අඳුර ගන්නවා. එතකොට carriersලා කියලා කියන්නේ මේ රෝගේ ඇත්තටම ගෙනියන කට්ටිය. ඒතර 100%යි ඉන්නේ. එතකොට මේ 100% දෙනාගෙන් 100%කින් 90ක් විතරයි අර ටෙස්ට් එක පොසිටිව් වෙන්නේ. Now okay. Then 5% detection rate for the non-carriers. Non-carriers means 99% are not carriers නේ. දැන් 99කට මේ රෝගේ නෑ කියලා පේන්නේ. හරිද? එතකොට එයාලටත් මේ ඩිටෙක්ට් මේ ටෙස්ට් එක කරනවා ඩයග්නොස්ටික් ටෙස්ට් එක. එහෙම ටෙස්ට් එක කරාම ඒ වුණාට එයාලට නෑ කියලා තිබ්බට 105 දෙනෙක්ට ප්‍රූව් වෙනවා මේක තියෙනවා කියලා. Now okay. දැන් ආන්සර් එක ලියන්න. එතන මොකද common event එක in here? Test was the positive. නේද? ටෙස්ට් එක පොසිටිව් වෙන එකනේ. දැන් අර කොවිඩ් කාලේ මත බලන්නකෝ දැන් කියන්නේ රෝග ලක්ෂණ තිබ්බු අය හිටියේ නැති අය හිටියේ. නේද? ඒතකොට ටෙස්ට් එකෙන්නේ ඔප්පු කරේ මෙයාලට ඇත්තටම තියෙනවද නැද්ද කියලා. ඒතර රෝග ලක්ෂණ තිබ්බත් ටෙස්ට් එක නෙගටිව් වෙන අය හිටියේ. මේ වගේ කතාවක් තමයි කියන්නේ. දැන් පුළුවන් මේ. අස්මී දෙන්නේ මේක. See, 1% of all individuals in a certain population are carriers of a particular disease. Then 1% are the carriers. Then 99% are the non-carriers. Okay. Then we look at their test was positive or negative. Get them and then some other identified. Seeing it, you identify are they carriers or non-carriers? First two branches is 1% and then 99%. Okay, then we do the diagnostic test and detect is a carrier or non-carrier. ඉන්නකට අපි ඩිටෙක්ට් කරගන්න අත්තම මෙයාට මේ ඩෙඩේ තියෙනවද නැද්ද? දැන් ඒක කියන්නේ population එකකින් 100 දෙනෙක්ට ඒ දෙකේ තියෙන carriersලා කියන්නේ රෝගයේ තියෙන. එයාලා තමයි ගෙනියන්නේ. 99කට නෑනේ. ඒනට අපි ටෙස්ට් එක ඔක්කොටම කරනවානේ සාමාන්‍යයෙන්. ටෙස්ට් එක කරාම අර 100කට තියෙනවා කියලා දෙන්න ඔක්කොනානේ. ඔයාලට රෝග ලක්ෂණ වලින් මොන හරි තියෙනවා. එතකොට එයාලට අපි ටෙස්ට් එක කරාම මේකෙන් 90%කටම ඇත්තට මේක තියෙනවා. ටෙස්ට් එක පොසිටිව්. 100කට ඊට පස්සේ ටෙස්ට් එක කරාම non carriersලට හැබැයි ඒකිනු ඩිටෙක්ට් වෙනවා 105 දෙනෙක්ට ඒක තියෙනවා. එහෙම වෙන්නේ. කොහොමද ඒකේ percentage එක අඩු වැඩි වෙනවා. 1% කියලා 90ක් ගිහිල්ලා අර 99% 5% ආවේ. යාලා සුබාව කියන්නේ මේ non carriers. හැබැයි අර ටෙස්ට් එකේ ඩිටෙක්ට් වෙනවා 5% කට තියෙනවා.
Test is positive. If test is positive, there are two chances. And the question asks, what is the probability that the individual can device probability? Then okay. Question which theory we can apply. Then question the test was applied to the flat sample from the randomly selected individuals and test was positive. Test was positive means detect that person is a carrier and detect the record. Then there are two chances in here, this one and this one. Section asks, what is the probability that the individual was a carrier? Then only this one. Then this is a revised probability. And we can use the Bayes theorem. මුලින්ම detect කරගන්න. උතර test එක positive එක තමයි first event. As the B කියන්නේ. Then first event always be right in first time. Then what is the second event? And is the conditional compound. A intersection B means 1% into 90%. Then in here probability of D. Then there are two chances. Carriers may be detected or carriers then their test was positive. Then non-carriers also test was positive. Then the two. The test was applied with the blood sample. Blood sample level is from a randomly selected individual that the test was positive. Means detected he or she is a carrier. Then how many chances in here? There are two chances. Test positive non-carrier test positive. What is the probability that the individual is a carrier? Okay, then in here there are two events. They detect their test was positive. Okay, then after that, then what's the probability of that individual was a positive event. Positive event කියවම අවස්ථා දෙකක් තියෙනවා. ඒකෙන් අපෙන් අහන්නේ එයා ඇත්තට මේ රේඩියේෂන් එක කෙනෙක් වෙන්න තියෙන probability. රිවයිස් එකක් කියනවා. එතන මේ ට්‍රී ඩයග්‍රෑම් එකේ නම් මේක බලන්න. This way, then detect the test was positive. There are two chances. This one and this one. Okay. Then what is the probability of that individual is the carrier? Only first one. Then your denominator is these two chances together. What's the numerator? Only is favorable. අපි හිතමු මේක දෙන්නේ ගැන කතා කරනවා. ඒක joint or conditional. Joint එකේ දෙන්න දෙන්නාම එකට වෙන්නේ. හැබැයි මේකෙම කියන්නේ ටෙස්ට් එක පොසිටිව් නෑ බත් හාස්පිටල් ඇත්තට මේක රෝග වාහකයක් නෙවෙයි. ඉතින් එකක් ඉවර වෙලා එකක් නේ. ඉතින් අපි කියන්නේ කන්ඩිෂන්. මුලින්ම වෙන්නේ මොකක්ද? මේ කතාවට ටෙස්ට් එක පොසිටිව්.
ටෙස්ට් එක පොසිටිව් වෙන්න පුළුවන් විද්‍යාවක දෙකක්. ඒක නේද යට තියන්න වෙන්නේ පොසිටිව් ඉවෙන්ට් එක. සෙකන්ඩ් ඉවෙන්ට් එකේ රූල් එක. සෙකන්ඩ් ඉවෙන්ට් එකෙන් කියන්නේ එයා අතරම ටෙස්ට් එක පොසිටිව් වෙලා එයා රෝග 1000ක් එක්කනේ. එහෙම තියෙන සංකල්පයක්. ඒක තමයි අපි රූල් එක. එයාට තියෙන්නේ අක්කෝ. Now understood. Probability of that individual in the test score for the name. How the started is assignment. අනිත් එකක් තියෙනවා එක කරගෙන යනකොට මේල් එකක් දාන්න. ඉතින් සත්‍යය ගියා තාම එක මේල් එකක් අස්සන්නේ. මට දාන්න නැත්තම් ගයිඩ් එකක් ඔයා මොකක් හරි ප්‍රශ්නයක් මේල් එකක් දුවහම නම් මට මට උඩ පොඩ්ඩක් රිමයින්ඩ් එකක් දාන්න ප්ලීස් මගේ නම්බර් එක ගත්තට මම
මම ඇත්තම අහන්න හිටියේ මට මගේ ශ්‍රී ලංකාවේ ඉන්න කොහොම බලන්න හිටියේ මට රිප්ලයි එකක් මට දාන්න ඉතින් ඇනලිසිස් එකේ තියෙන විදිහට අපි data set එක අරගෙන මේ විදිහට කොහොමද
නෑ ඒක ඔයා මිනිමම් 2 pages එක තියෙන්නේ නැත්නම් අර graph එක අපි insert කරාම page එක බලන්න ලියන්න ඕනේ analysis interpretation එක තමයි මාත් දෙන්නේ. Then first paragraph you describe about your data set. මේ data set එක මොකක්ද මේකේ තියෙන variables වර්ග මොනවාද level of requirement ඒක බේස් කරගෙන ඔයාලට ඇනලයිස් කරන්න නේද මොන chart එක දිනු කරන්න පුළුවන් නේද ඊළඟට මොකද්ද summary measure සූත්‍රයේ මම කියනවා qualitative type වේලා අපි use කරන්නේ central tendency වල movement එක නේද quantitative kind එකක් quantitative type එකක් නම් we can use the mean median not both take all of them okay and using the variance standard deviation then ඔයාලට data set එකක් හම්බුනොත් group දෙකක් තියෙනවා ये देखिए कैलकुलेट करते हैं कंपेयर करना असाइनमेंट सुना दिया सामा पाले ये कोई कुछ नहीं होती है उसके कारण ना तब ना हो जाता है आज लोग पालन देगी इधर देखते हैं इधर का क्रिया विज्ञान में क्या हम इतना है इतना में हम समझा करते हैं तो मैं असाइनमेंट तो मैं करा सकते हैं इतने वाला घंटा देखती हूँ क्लास असाइनमेंट का देखना तो මේක ඉතින් දක්වන්න කෙනා ඉඳලා ඉන්නේ. මම ඉෂුස් ඒවා නම් තේරෙන එක කියන්න බාගෙට කර හරි මෙහෙමයි මම කරේ මේක ඕකේද කියලා හරි කමන්නේ. LNS එකේ මේල් ඇඩ්‍රස් එක දී. ෆෝන් නම්බර් සම්මත දුන්නු කන්නේ. ඉන්න දෙන්නේ නෑ. මේක අත. Excel එකට ඇඩ් ගිහිල්ලා data analysis කියන එක ඉන්සර්ට් කරගන්න. එතකොට මොකද ඉෂුව එකක් නැහැ. මාළගේ data set එකට දාලා mean median one variance standard deviation part and document. ඒක මම මොනිටර් කරලා කරන්නේ. data set එකේ sample size එක ගොඩක් ලොකුයි නම් ඒකේ කොන්ට්‍රාස්ට් එක ගන්න. ඉතින් කරන්නේ ඔබ දාන්න කියලා ඔබ Excel එකේ කරපු දේවල් ඉතින් sample දාලා insert කරලා තියෙන්නේ මේ කාලේ report එක මොනේ copy කරලා තියෙන්නේ. ඒක කවුද copy කරේ කියලා හොයන්න බෑ. දෙවෙනියට එක්කනට marks අඩු වෙන්නේ. දැන් copy කරලා ඉතන මුලින්ම මන්නත් පුළුවන් නියම වෙලා තියෙන්නේ. දැන් කවුද මම දන්නේ නැහැ. දෙවෙනියට එක්කනට marks. හරිද? මොනාරි ප්‍රශ්න තියෙනවා නම් මෙහෙම දෙන්න. ඩායෝ දාලා තෝරම කරන්නේ කවුද දීපම් පාල්තිය. නේද? है बाहर किया ना ये ना पैसा गया वो आई ना साल के जो असाइनमेंट लगे करना दे पास हम पूरा करना ट्राई करा ना कि चैट जीपीटी डाटा दे पा ये वाला डिलीट कर गया नहीं हुआ और अगर सोचता भी नहीं कोई लोग हैं जल्दी बात से ना ये वो है अलग ही ඒකනේ data set එකක් Google එකේ යන පුළුවන් විදිහට ලියන්න. ඒක ඔයාලා උනන්දු වෙලා තියෙන කොහොමද කියන එකෙන් මතක් මාක් දෙන්න පුළුවන් නේ ඔයාලා හරි දෙයක් කරන්න. copy කරලා තිබ්බොත් දෙවෙනිට වගේ තියෙනකොට ගණන් අවුල නැහැ බොයිස් තමයි ඉවර. ඇයි ගර්ල්ස් එක්ක කරන්නේ අපේ නන්නක වෙන්නේ. सामान करना बार-बार कितना जरूरत है असाइनमेंट करना है ना रात में साल ये वाला पेपर डालना सामान असाइनमेंट करना basically then 30 marks from CA continuous responsibility 30 marks. The 70 තමයි final paper එක. Final paper එකේ ගොඩක් වෙලාවට මම දෙන්නේ ඔයාලට output interpretation තමයි. එහෙනම් දැන් ඔයාලගේ level එකට නිකම් ප්‍රශ්නයකට උත්තර ලියන්න පුළුවන් දෙයක් expect කරන්න එපා. දැන් මේ lesson එකේ මම ඉලා කිව්වානේ. අන්තිම වෙලෙදී ඔක්කොම output interpretation විතරයි මම උගන්වන්නේ. You need to do the hypothesis testing, ANOVA, regression analysis. ඒවා හැම එකක්ම අපිට software එකකට output ගන්න පුළුවන්. Important එක තමයි interpretation එක. මේ output එක ඕන software එකකින් output එක ගන්න පුළුවන්. output එකෙන් interpret කරලා මොකක්ද අපිට ගන්න පුළුවන් decision එක කියන්නේ තමයි. ඒ probability lesson එකේ නම් ඉන්න පුළුවන් දෙයක් වෙන්නේ නැහැ. ඊට අපි start කරන ඊළඟට අපි next day we will start the normal probability distribution. That's a regression and over hypothesis. Now time series එකක් තියෙනවා. පුළුවන් තරම් try කරනවා time එකත් එකක් කරන්න එකක් ඕන වෙන්නේ නැහැ. අර ටික වැදගත් වෙනවා. Final year research එකට ඕනි වෙන ටික. Analyze part. Practically ඔයාලා කරනවා analyze part එකේ analysis නම් ඔයාලා job එක analyze කරන එකක් නේද? ඔය use කරන්න පුළුවන් ලේ. business field එකේ ඔයාලා අදම තමයි chart එකකින් හරි analyze කරනවා නේද? presentation එකම කරන්න වෙනවානේ. එතකොට හරි chart එක මොකක්ද කියලා හරි තෝරගන්න ඕනේ නේද? දැන් ඒකට can chart සම්බන්ධ බෑ. ඒක depend වෙනවා අපි use කරන variable type. software එකේ ඕනම දෙයක් අපිට දෙනවා. ඒ යාලා කරන්නේ අපි feed කරන දෙයට output එක දෙන්න. යාලා වැඩි කියන්න බෑ. අපි ඉත basic idea එකක් needs එකයි අපි කරන්නේ මොකක්ද objective එක. එහෙනම් මේකේ result එක interpret කරන්න ඕනේ. Excel එකේමයි regression එකකට try කරමු. එයාලා මේකදී බලන්න ඉඳලා හරි ගෙදර ගිහින් try කරගන්න පුළුවන් නේ. එහෙනම් දැනට Excel එකේ අර ඉන්නේ ගිහිල්ලා අර data analysis එකට දාලා තියන්න. අර first එකට පුළුවන්. බලන්න try කරන්න. ඉතින් මම හිතන්නේ lab වල ඇති. මම කියලා දැම්මොත් අත්ත final year ළමයිට distance analysis subject එකට. ඔයාලට උනා මේවා use කරන්න දෙනවා නේද? weekends use කරන්න බැරිද? මම හිතන්නේ එක lab එකක් පොඩි වෙලාවට use කරන්න පුළුවන් මේක කියලා. ඒක තියෙන්නේ. අඩුම තරමේ මෙහි ඇවිල්ලා අපි ඉවරනට තුනට ඊට පස්සේ අර assignment එක කරලා යන්නකො. අක්ෂර දිශීනා 3:30 assignment එක කරලා කරන්න පුළුවන්. මම 6 වෙනිකන් ඉන්නවා ඉස්කෝලේ යන්න තර කාම. හරි? දැන් අපි කරන්නේ. They might come in here. Means 0.9 equals 0.05. Then in here there are two things not to this one and this one. Okay, to start. Okay. Then I uploaded another first sheet.